Hi children, welcome to Gagan Online Academy. In this video, I am going to present the chapter motion for class 9. It will be useful for AP and Telangana students and other state board exam also. Motion. This is one of the important chapters in physics. You see, trees, houses, factories, these are fixed. They won't move. They don't move. So that's why they are called stationary objects or stationary bodies. Tree, right? Factories, trees, factories, houses, they are stationary. They won't move. So that's why they are called stationary objects. Stationary objects. Men run on the road, car, buses, they move on the road. Birds, aeroplane, they fly in the air. They have movement. They are moving bodies. They are in motion. Writing here, cars, buses, they travel on roads. Birds, aeroplane, they fly in the air. Fish swim in water. Fish swim in water. These are having motion. They are moving. That means these things are in motion. These things are in motion. Simply motion means movement of a body. Movement of a body is called motion. Movement of a body is called motion. Movement of a body is called motion. All moving bodies have one common character. All moving bodies have one common character. That is, they change their position continuously. They change their position continuously with time. With time. I am explaining, taking one example. Say here a car. I'm not good at drawing. Okay, simply see this is a car. Okay, here is a house. In front of this house, this is a house. Okay, say this is house. In front of this house, A is here. A car is there at position A. At in front of this house, there is a car. Okay, at position A, car is here. This is in front of a house. Now it started moving. After 5 minutes, say after 5 minutes, it reaches the point B. This car reaches the point B. Point B. After 5 minutes. Now the car is 5 far away from the point, far away from the initial point. Earlier it is at point A. Now there is a change in position. Now it changes its position. Now its position is B. After certain time, 5 minutes, with reference to this house, right? From this house, we are taken as reference. From this house, this car changes its position. Earlier, the position of car is A. Now the position of car is B. So change in position. See what is happening here? Change in position. That is called motion. So a body is said to be in motion. I am writing it. A body is said to be in motion if its position changes continuously. Changes continuously with reference to a stationary body. Stationary body. Here stationary body is house. This is stationary. With time. With time. So this is the definition for motion. Car is changing its position with time with reference to this house. This is motion. In order to understand the motion of objects, we must know some terms. That is distance, next displacement. Distance and displacement. Let us discuss these two physical quantities, distance and displacement. To understand this distance and displacement, let us take one example. Suppose there is a point A, here there is a point B. I have to reach B from the point A. I have three ways. See, one is in this direction. I can reach in this path. I go in this path and I reach B. Another way is in this path. This is path 1. This is path 2. I can travel in this direction. I walk and finally I reach B. Another route, this is third path, straight path. This is path 3. So to reach B from point A, I have three paths. This is path 1, this is second path, this is path 3. If I go in this path to reach in this path, it will be 7 kilometers. It will be 7 kilometers. If I travel in this direction, if I walk in this direction, the distance is 80 kilometers, say 10 kilometers. Okay, no problem, 10 kilometers. If I follow this path, it is only 5 kilometers. 5 kilometers. Now, this 7 kilometer, A to B, I choose one path. This is 7 kilometers, right? This 7 kilometer is called distance. Is called distance. Distance traveled by me, that is 7 kilometers. This is path 1, right? Path 1. If I take second path, in this case, distance is 10 kilometers. Distance is 10 kilometers. Now I am asking you, what is the displacement? Displacement. Displacement is initially I started journey here. Finally, I reached B. So the shortest distance between this final and initial position, this distance is called displacement. So this is 5 kilometers. So displacement means the line joining final and initial position, or in other words, shortest distance between 2 points. This is the shortest distance. So that is called displacement. A to B in this path. This path indicates distance only. This path also indicates distance only. This path is called displacement. Okay. One relation between distance and displacement. See, distance is always greater than or equal to displacement. This you have to remember. Distance is always greater than or equal to displacement. See, let us see. Say first case. What is the distance in the first case? In the first path, 7 kilometers. I am writing 7 kilometers. What about displacement? 5 kilometers. This is first case. Okay. Second case. What is the distance here? 10 kilometers. Displacement for all the cases 5 only. Displacement is 5 only. A to B is displacement 5. Third path. What is the distance here? 5 1. What is the displacement for A to B? 5 1. For this A to B, distance is 5 and also displacement also 5. See now, 7 greater than 5, 10 also greater than 5, 5 is equal to 5. So these three statements combinedly we can write as this 7, 10, 5. These are distances. 5, 5, 5. This is displacement. So see 7 to 10, 5 are greater than or equal to. So distance is greater than or equal to. Here greater, here equal symbol. Greater than displacement. If we are given what is the relation displacement and distance. Now in this case, we put less than or equal to. Less than or equal to. I hope you understood this concept. One more example. I am taking here. This is A, this is B, C. Three positions are given. To reach, I am writing C. Here I am writing B. Erase and erase, erase. I am drawing one right angle triangle. Here is A. Here B I am writing. Here C. I want to reach the point C. This is my initial point. This is my starting point. From A, I have to reach C. I have two ways. One is C. First, I go to B, then B to C. First, I go in this direction, east direction. Again, north direction I will go. And I reach the point C. This is one way, one path. Or another path is directly I am going to the point C. This is directly I am going. Shortest distance, shortcut. Okay. This AB plus BC, AB, A to B, AB plus B to C, BC. This distance is called, this is called distance. This is called distance. See, suppose say this is 3 kilometers, this is 4 kilometers. This is 4 kilometers, this is 3 kilometers. So from A to C, distance, total path traveled by this, by me is distance. Here, A to B, 3 kilometers I walked. From B to C, 4 kilometers I walked. Totally how many kilometers I walked? 4. 3 plus 4, 7. So 7 kilometers is distance. Is distance. Now, for the same picture, I am asking you, what is the displacement? What is the displacement? Displacement is shortest distance between 2 points. Means final point and initial point. This is the initial point. This is final point. I reached C. If we join these two final and initial point, we get a line. This line gives us displacement. Displacement is final position minus initial position. So this value I have to calculate. So this is rectangle triangle using one formula, Pythagoras theorem, that is AC square. AC square is equal to AB square plus BC square. AC we don't know. AB is 3 kilometers. I am writing 3 square plus BC value is 4 kilometers. 4 square, 3 3 is 9, 4 4 is 16, 9 plus 16, 25. Okay, I want only AC, not AC square. AC is equal to 25. Square goes this side, becomes square root. Square root of 25 is 5. So AC is what? 5. This is the displacement. 5 kilometers is the displacement. Another instance I am going to explain. This is one circular path of radius 7 meters. A boy starts journey from this point. Okay, from this point he traveled along this circular path. He reached this point, same point. Okay, for this distance, I am calculating distance. To find distance, how many kilometers he traveled? Okay, we use 2 pi r. This is length of this circumference is 2 pi r, perimeter. Okay, circumference we call it. Circumference of a circle is 2 pi r. Using this 2 pi r, this total length, right? You can calculate. So 2 pi is 22 by 7, r is 7. So 7, 7 cancel, 44 meter. 22 into 2, 44 meter. This is the distance. I want displacement. For this question, what I want? Displacement. I told you shortest distance between final and initial position. Difference between final position minus initial position. That is displacement. See, initially it is the boy is at point A. After some time, again he reaches the same point, same position. That means earlier position and final position are same. There is no gap. That means displacement is zero. There is no change in position. Earlier he is at this position. After some time also, there, he reached the same position. That means there is no change. There is no gap between these 2 points. So that's why displacement for this is zero. That means distance won't be zero. Distance won't be zero, but displacement can be zero. Sometimes displacement zero, it becomes zero. But distance always, it must not be equal to zero. It has certain value. But displacement in some cases we get zero. In this case, displacement is what? Zero. I told you motion, right? Movement of body is called motion. Now we have uniform motion and non-uniform motion. Motion is of two types, uniform motion and non-uniform motion. Non-uniform motion. If a body moves equal distances in equal intervals of time, then we say the body is in uniform motion. Here, equal distances in equal intervals of time. In equal intervals of time. Equal intervals of time. If a body moves, if a body travels equal distances in equal intervals of time. Important points I am writing on the screen. If a body travels equal distances in equal intervals of time, then we say the body is in uniform motion. One example I will tell you. Suppose a car starts traveling journey at point A, right? After some time, here, in first 1 minute, it travels 5 kilometers. In second minute, it covers 5 kilometer distance. In third minute also 5 kilometer it covers. See, in first minute, again here in the second minute, in the third minute, right? First minute means 60 seconds. Second minute also 60 seconds. 60 seconds. In first 60 seconds, it covers 5 kilometers. In the next 60 seconds, it covers 5 kilometers only. In the next 60 seconds, it covers 5 kilometers only. That means here interval time is same. See 60 seconds, 60 seconds, 60 seconds. Or you say 1 minute, 1 minute, 1 minute. In 1 minute, 5 kilometer distance. In the second minute also 5 kilometer only. In the third minute also, it covers only 5 kilometers. Equal intervals and equal distances. So now I can write a body, if a body travels, equal distances in equal intervals of time, equal interval of time, then the body is said to be in uniform motion, in uniform motion, right? Now, non-uniform motion. Graph of a uniform motion is always a straight line. Graph of a body which is in uniform motion. Graph of a uniform motion is always a straight line. Always a straight line. This is one important bit, this one. Straight line. That we have to prove. Now see, this is x-axis, this is y-axis. On x-axis, we must take time. Here on y-axis, we have to take distance. On y-axis, we have to take distances, right? This is first minute, second minute, this is third minute, this is 4. First minute, second, 3, 4. Distance here, 5, 10 kilometers, here 15 kilometers, 15 kilometers. Like that you can take, okay? Now see, here I told you, in the first minute, okay, it covers 5 kilometers. In the second minute, it covers only 5 kilometers. In third minute also, it covers only 5 kilometers. That means in the first minute, right, it covers 5 kilometers. In 2 minutes, it covers, see, 2 minutes means from here to here, 5 plus 5, 10 kilometers. In 2 minutes, it covers a distance of 10 kilometers. In 3 minutes, see, in 3 minutes means the body reached here. 5, 5, 5. Totally, how many 5s? 3, 5, 15. 50 kilometers traveled. Okay. Now for this, I am drawing graph. In the first minute, it travels 5 kilometers. So here 5 kilometers. In 2 minutes, it travels 10 kilometers. So from 2 start, go and write, put 10 here. In 3 minutes, it covers 15 kilometers. So in 3 minutes, go up distance 15, see here 15. Now join this line. It is at the rest here. This point is 0 at the rest. So you can write 0. Now join this line, dots. What I got? Straight line. Okay. Graph of uniform motion is always a straight line. Now let us discuss non-uniform motion. Non-uniform motion. If a body covers unequal distances in equal intervals of time, then we say the body is in non-uniform motion. I am writing its definition. If a body covers unequal distances in equal intervals of time. Equal interval of time. The body is said to be then. The body is said to be. The body is said to be in non-uniform motion. Non-uniform motion. Let us take one example. Trains, buses, scooters, they have non-uniform motion. Say a train starts from station A. This is a train here. A train starts from station A. Okay. Different stations are there. In the first minute, okay, first second or first minute or in first hour. You can take anything unit time. So initially it covers a smaller distance. Say in the first minute it covers only 5 kilometers, only 5 kilometers, because it starts from the rest. Okay, that's why it moves slowly in the beginning. Initially, in the first minute, initially it moves with slowly it moves. After this 1 minute, it covers, in the second minute, it covers, say, 13 kilometers, 13 kilometers, right? Now again, it increases, it covers 20 kilometers, it covers 20 kilometers in the third minute because speed is increased, right? In third minute, it covers 20 kilometers. In the second, only 13 kilometers. In the first minute, it covers only 1 minute. At some time, when the stations approach, they reduce their speed. Okay. Now see equal intervals of time. Here 1 minute only. Here 1 minute only. Here 1 minute only. In the first minute, 5 kilometers. In the second minute, it covers 13 kilometers. In the third minute, see, it covers more distance, 20 kilometers. Unequal distances, equal intervals of time. Then we say this body is in non-uniform motion. Graph of non-uniform motion. Non-uniform motion is a curved line. We call it a curved line, not straight line. Let us draw a diagram. You can understand it clearly. Right? On x-axis, what do we have to take? Time. On y-axis, we take distances. Distance. Okay. Generally, we use these units, meters, distance is in meters, time is in seconds, according to SI systems. Okay. That's why in your book there will be, you are given seconds to meters, right? Not kilometers hours. For understanding, I can take anything. We can take anything, right? Okay. This is in first minute, second minute. This is third minute. I am writing here 5. Here I am writing 10. Here I am writing 15. Here I am writing 20. Okay. Between 10 and 15, I have 13 here. 13. Okay. Say I am drawing graph. See, this is x-axis. I am drawing y-axis. 1 minute, 2 minute. First minute is 0, rest position. 2 minutes here, 3 minutes. In 1 minute, that means in the first minute, it covers 5 kilometers. It covers 5 kilometers. Next, in 2 minutes, first minute 5, second minute 13. Totally 18 kilometers are covered. 18 kilometers in 2 minutes. In 3 minutes, how much distance is covered? See, first minute 5, 13, second minute, in third minute 20 kilometers. Together, 5 plus 13, 18, 18 plus 20, 38. 38 kilometers are covered, right? In the first minute, it travels 5 kilometers. In 2 minutes, 18 kilometers. In 3 minutes, it covers 38 kilometers. Let us draw a diagram. This is 5. This is 10, 15, 20, 25, 30, 35, 40. Right? Here 38, there will be 38. See, just imagine. Now see, in first minute, so here 5 kilometers. So put point at 5. Next in 2 minutes, see 2. From 2 we have to start, go up to 18. So here is 18. See below 20, right? Here is 20. 18 means here. Next 3 minutes, 38. So from 3 I am going 38 means here. My diagram is, my photo is there. So that's why I am writing here. Or I can, okay. Now draw this, join this point. See, I am getting one curve. I make my photo, I place another place. Okay. Now see, 38, 3 here, 3 to 38, it comes here. Now join this point, what I get? One curve I got. What I got? One curve. Not straight line. I got one curve. That means graph of non-uniform motion is a curved line. Motion of a body can be described by three important terms. Motion of a body can be described by three important terms. Three important terms. They are speed, second one velocity, so third one speed, velocity and acceleration. Let us study them in detail. If a car is running slow, we say its speed is slow. If a car is running slow, we say that its speed is low. If a car is running fast, we say its speed is high. That means how fast or how slow a body is moving, that is speed. So we get one idea about how fast or how slow a body moves, that is speed. Speed is distance traveled per unit time, defined as distance traveled per unit time. So we write it, speed is equal to distance by time. Now let us know what is average speed. Average speed. See, speed is defined as distance upon time. Distance is measured in meters, time is measured in seconds. So unit of speed is meter per second. Meter per second. Or you can write ms to the power of -1, right? These are unit. Average speed. Average speed of a body is defined as total distance covered. Total distance covered divided by total time taken. Total time taken to cover that distance. While moving in a car, we have noticed that at some places we have to slow down or we have to stop due to some reason. If the road is flat, no traffic or no curves, then we go with high speed. Right? Suppose I cover 100 kilometers in 4 hours. 400 kilometers in 4 hours. Now I'm calculating average speed. Average speed. Total distance, that is 100 kilometers by total time 4 hours. 100 by 4, that is 25. 4 2 ja 4 5 ja. 25 kilometers per hour. Meaning, see, it is not moving with 25 kilometers every hour. That is very, very important. At some time, it will be slowed down. At sometimes it move with high velocity, right? Its average velocity is 25. Average velocity is 25. Write total distance in numerator and total time in denominator and divide, you will get 25 kilometers per hour. But you should not assume as average speed is 25 kilometers means it is always, in every hour it is moving 25 kilometers. That is wrong. The speed of a car The speed of a car gives an idea of how fast or how slow the car it is moving. How fast or how slow it is moving. But it is not giving in which direction it is moving. So for this, we need one more term, that is velocity. Velocity is defined as distance traveled by a body in per unit time in a given direction. So direction is important. Distance traveled, distance traveled per unit time, per unit time in given direction, in a given direction is called velocity. So I am writing velocity is equal to distance traveled, right, in certain direction. If it has direction, that distance is called displacement. So I am writing displacement by time. Distance traveled per unit time in a given direction. Okay. If direction is mentioned, that distance is called displacement. So displacement by time. If displacement is measured in meter, time is measured in second. So for this also we can write meter per second. But you must mention direction, east direction or north direction or south or northeast like that. Otherwise it is considered as speed only. So after writing this meter per second, mention towards you must mention direction towards north, towards east, towards northwest like that. Then only it is called displacement. Now let us discuss uniform acceleration, uniform velocity, uniform velocity. If a body moves in a specified direction, if a body moves in a specified direction, if a body moves in a specified direction in straight line, covers equal distances, or you can say displacement, right? Equal distances or displacement in equal intervals of time, in intervals of time, equal intervals of time. Then we say the body is moving with uniform velocity. Velocity can be changed in two ways. Velocity changed in two ways. Velocity can be changed in two ways. One is by changing the speed of an object. By changing the speed of an object. Second one, by changing the direction. By changing the direction. To understand this, I am explaining one thing. Suppose a body is moving in the first hour 25 kilometer per hour. Okay. In the next second hour, it travels 50 kilometer per hour. Okay. There is change in speed. Change in speed. So change in speed means velocity also changes. One more example. A body is moving here 50 kilometer per hour in east direction. Next, it took left turn and moving in north direction with the same speed, 50 kilometer per hour. In this case, I say the body is moving with constant speed. constant speed. See, in this direction, it is moving with 50 kilometer per hour. Everywhere it is moving with 50. In this direction also, it is moving 50 kilometer per hour. Then I say constant speed. But we should not say constant velocity. Though the speed is same, but direction is changed. Direction changed. So that's why velocity is changing. Here, this is not constant velocity. Direction changes means velocity also changes. So velocity changed now. Velocity changed. Due to direction, velocity is changed.